Okay, welcome to week 5. This week we're going to talk about plotting data. So producing visualizations off of your data is going to be the focus of this week. So this again hits on all 5 of the course learning objectives. And it's going to have a Jupyter notebook just as we've talked about in previous weeks. Now again, I'll draw your attention to the cheat sheet that I had provided earlier. It's available in the Getting Started resources. This is the cheat sheet for MatPlotlib, which is going to be the first of the graphing libraries which we're going to go through in the course. And so here you can kind of see different steps within creating a plot. So first of all, preparing the data, next creating the plot, and then different kinds of adjustments you can make to the plot. You can customize it, different kinds of plots. You can do things like auto scaling, etc. So it's quite useful and it's quite flexible as well. This particular cheat sheet was provided by DataCamp for us. So let's get right into the demonstration script right here. So again, the objective is to perform some basic data visualizations. In this example, I'm going to do 5 things. I'm going to create a stacked area plot of the provided data set with the years and the x-axis and the total sales of each car brand on the y-axis. And that stacked area should show the sales of the cars with different types: petrol, diesel, hybrid, electric. So it's quite a complex type of plot we're going to do for this first one. Second one is going to be a scatter plot. So these are bread and butter of all data science activities. Typically, you'll start off with a scatter plot to look for relationships, such as linear relationships. Using that provided data set, we're going to look at the horsepower on the x-axis and the weight on the y-axis, with marker size indicating the car price. So again, it's not just a normal scatter plot, it goes beyond that. Third, we're going to create a bar chart. Provide a data set looking at car brands on the x-axis and total sales on the y-axis. Doing bar charts are, again, a standard thing in your toolkit that you'll use. Creating a pie chart, so showing kind of percentages of a total of the provided data set with percentages of metals won by each country. And finally, a heat map. Heat map is, again, something very common in visualization. So showing a heat map of the provided data set with the car brands in the x-axis and the average price, horsepower, and mileage on the on the y-axis, average price, horsepower, and mileage on the x-axis. So in this case here, the deliverable is this Python file that we are creating, this Jupyter notebook. I'm not going to have any additional text files that's associated with it. The grading criteria is consistent with all previous weeks that we've talked about. So first of all, let's generate some data. I'm just going to generate this using Pandas. So we went over Pandas in a previous week. In this case here, I'm just going to create a data set that's going to have years, brands, petrol numbers, diesel numbers, hybrid numbers, and electric numbers. Using the data frame keyword, I'm going to go ahead, data frame function, I'm going to go ahead and use this data, and I'm just going to create a data frame, a Pandas data frame. I'm then going to turn around and drop that off to CSV. So I have a copy of that I could use again. I'm going to repeat the process, generating some additional data for brand, model, price, horsepower, weight, and mileage, and drop that off to a CSV. Third, I'm going to create one of metals, so the country, the gold, silver, bronze, and total counts of metals. So by using these 3 Pandas routines right here, I'm going to create the data that I will use in the rest of the notebook. You're able to do the exact same thing as well. Again, I'm using this particular directory right here. So if you're going to run it yourself, you want to go ahead and make sure you replace that with like your C drive or wherever you store your data. You'll want to change that path to your path and then keep the file names on the back end the same. So the first one is creating the stacked area plot. I'm going to load MatPlotlib. And so again, the keyword of plyplot is the part of the library that I'm interested in. And the common naming convention for MatPlotlib is PLT. So I'm going to keep that consistent, and as we discussed with Pandas. First thing I'm going to do here is I'm going to read in the CSV file from that file that I just created. And then I'm going to set the index of that file to be the year. I'm going to start generating the figure down here. So I'll create 2 variables right here. and then use subplots because I'm going to do things inside of it. I'm not just doing a simple stacked area plot. I'm doing it with that, again, that third piece of that. So by doing this, I use a stack plot. The first one here is the data frame, and I'll use the data frame using the index that we just created. Going to break off the data frame by petrol, diesel, hybrid, electric. And then I'm also going to add this optional keyword of labels so that we get these nice pretty labels here as well. I'm going to use legend keyword, and so the legend will allow this little legend to show up right here, and I want that placed in the upper left. Now I can modify this to change it to different places, a lower right, lower left, etc. And then finally the plot show. So if I go ahead, I'm in, again, Visual Studio Code. If I go ahead and run that, it takes a minute, and then it pops it back out. It gives us the nice, pretty stacked chart. Next, I'm going to do that scatter plot. So I'll use the same type of setup, pyplot, as plot, using pandas. I'll read in the file into pandas. Using the scatter keyword, the scatter function, and then within that, I'm going to highlight out the horsepower and the weight, and then as a subset, the price piece of it. Setting the alpha to 0.5 is a standard default. You can change that to different numbers. I'm going to set an X label and a Y label, and then do the plot show. So the key pieces of this is plot scatter and plot show. That will give you this this chart. If you want to add the additional things of titles here on the X and Y labels, that's the labels right here. And if you want to have it again, mark it out by different categories like this, you would use this additional syntax which we've got here. The next one is to create a horizontal bar chart of the provided data sets with car brands on the x-axis and the y-axis, total sales. Read it in, set the index, so we've done that a couple of times here. And then within total sales, I want to go ahead and create a sum. So for total sales here, I'm going to sort the values, so that gets you the highest to lowest. I'm then going to set up the plot using the sort values, and then I'm going to set up the plot and using the kind of bar and H. Bar horizontal is what that stands for. So again, at any time, if you'd like to see the individual pieces of it, you go back to the cheat sheet, and you can able to refer back to the cheat sheet right here. Okay, next, do the show. Here's the graph. Okay, then the next one is to create the pie chart. So we do the standard setup, which we just talked about right here. We're using the plot function right here, and kind, we're going to set it to pi. Now you have to set what the y-axis is going to be. So the y-axis is going to be total metals. And then the legend, I'm not going to put a legend on this. Okay. I'm not going to put plot labels, Y labels, and then show. And then finally the heat map. So the heat map right here, standard setup which we just did. I'm going to create subplots in this because I want to break it down within the individual heat map. And so then in there I'm going to set the range to be the length of the data frame. I'm going to show the pieces of price, horsepower, and mileage. And then for the y-ticks, I'm going to set the range to be 3 and set the labels to be price, horsepower, and mileage to match back to that. I'm going to use a color bar in this case and then do a show. So that's how you would do a heat map in it. That's just some basic plots that you can do out of it. Now, again, I imagine that there's going to be a lot of questions for office hours. So this is probably a week that you want to kind of take a look at it early on. And then if you have questions, come to office hours or post those up in the discussion forum. For your example, for your assignment here, again, remember the standard instructions of inserting your name. Create a line plot with a provided data set. and use years and population on the X and Y axis respectively. Create a scatter plot with horsepower and miles per gallon. So very similar to what we did in the example. A bar chart with car brands and average price. A histogram with salaries and frequency. A pie chart of percentage of car sales by each brand. A stacked bar chart provided with the years of the x-axis and the total number of medals won by country. The stacked bar should show the number of gold, silver, and bronze medals won. A box plot of the provided data set with the car prices grouped by brand. A violin plot of the provided data set with car prices grouped by brand. A hex bin plot provided of the car prices and mileage on the y-axis. And a 3D scatter plot of the provided data set, weight on the y-axis and miles per gallon on the z-axis. So there are examples of every single one of these in the reading as well. You can also find examples online of how to do a violin plot, a hex bin, for example, those options there. A scatter plot is the same type of scatter plot. You just use an additional parameter because you have the z-axis at that point. In most cases, the box plot, the violin plot, and the hex bin plot would be the thing that would probably get you most confused because we haven't shown you an example in the demonstration, but there are examples inside the reading. So make sure that you check that out, and if you have questions, put those back out on the discussion forums. So you modify this notebook and make sure that the 5 grading criteria are met as part of that. Make sure your code is as efficient as possible. This particular example, we're using plots, so a lot of these plots are going to be just a couple of statements. There's not going to be an issue with having to do a for loop or more complex type logic in order to generate the plot. So these are all very basic plots. We shouldn't have any problem with code efficiency. Make sure your code is clear and readable. Again, by putting it inside of this Jupyter notebook, we should be able to address most of that and make sure, do one last check to make sure everything is running and working correctly. So if you have any questions, please reach out, discussion forums, come to the office hours, or come, send out an email to your instructor and they'll be able to answer those questions. Have a good one. Thank you.